Okay, here is the November 2020 question on momentum. Remember, momentum is a vector, so everything we do here, we need to bear in mind it's going to have a magnitude and direction. So if we look at the question, it says ball P with a mass of 0.16 kilograms is moving east at a speed of 10 meters per second, collides head-on with another ball Q of mass 0.2 kilograms, moving west at a speed of 15 meters per second. So because this is a vector question, let's just have a quick look here and see which is the dominant vector question. If I look at ball P, the mass is smaller than the mass of ball Q. And if I look at its velocity, the magnitude of the velocity is smaller than that of ball Q. So in my mind, this is the dominant vector direction, which is to the west, because the ball Q is larger and it's traveling faster, so momentum is the product of mass and velocity, and this one will have the larger vector direction. So I would say to the west is the best vector direction. Then you have less negative numbers in your calculation. It says after the collision, ball P moves west at a speed of 5 meters per second as shown in the diagram below. They don't tell you what happens to ball Q, but it's a fair bet, seeing as it had the larger velocity, that it is probably going to keep moving to the left. Remember that if something bangs into it, if you have two objects that bang into each other like this, you can end up with the result that they move outwards, or if you've got two that move together like this, you can end up with both of them moving off in the same direction, either separately with different velocities or together as one object, or in some instances, if the vectors are paired, the momentum vectors are paired, they will just come together and not move at all. So the most likely scenario in this is that because ball Q had the bigger momentum to start with, it will probably move off to the west afterwards. And that's why I say the best option here is to be using to the west as positive. So it says ignore the effects of friction and the rotational effects of the balls. The moment they tell you this, we can use the law of conservation of momentum. Okay. And so you need this to be there if you want to use the law, because if you can't ignore friction, friction will take energy out the system and remove some of the momentum. Then it says to define the term momentum in words. So in the guidelines, it says the linear momentum of an object is the product of the mass and velocity. In this one, they just said momentum, so they will say momentum is the product of mass and velocity. This is a 2 or 0 definition. If you are not 100% word perfect, you cannot get both marks. So learn your definitions properly. Now it says to you, calculate the velocity of ball Q after the collision. Look here, it doesn't say calculate the magnitude. It says calculate the velocity. So we know that this is a vector. Our final answer must have a number, a unit, and a direction. It's also 5 marks. Usually when it's 5 marks, we go and use the law of conservation of momentum. So the first thing we do with a vector question is we pick a positive direction. So I'm going to say to the west is positive because that's where my larger initial momentum is. So if to the west is positive, this 15 will be plus 15 and this 10 will be negative 10. This 5 is also to the west, so this 5 will end up being positive. You can take to the east as positive, then you must just switch the signs, and your final answer for Q will probably come out with a negative value, which you then have to translate into a westerly direction if you have said to the east is positive. But we're going to go to the west is positive. So to the west is positive. We need to state the law mathematically. The sum of the initial momentum is equal to the sum of the final momentum. So it means that mass P with its initial velocity plus mass Q times by its initial velocity will be equal to the mass of P times its final velocity plus the mass of Q times its final velocity, which is what we are trying to work out. So the question tells you that P has a mass of 0,16 and Q has a mass of 0,2. So this is going to be 0,16 multiplied by negative 10 because P's initial velocity is easterly, which makes it negative according to my vector convention. And here, this is 0,2 times by positive 15 because we said west is positive. Now my final velocity, this will be 0,16 mass for P multiplied by positive 5 plus 0,2, and that final velocity we're trying to calculate. And whatever the sign is will tell us the direction. So if we do some maths here, we end up with something like 0,6 is going to be equal to 0,2 VF. I assume you can all use your calculator. So 0,6 divided by 0,2 gives you an answer of 3. And this is a positive 3. So the final velocity of ball Q is going to be 3 meters per second. It is a vector. It will be positive 3 meters per second to the west because we said that was our positive direction. Now it says to you, what is the magnitude of the impulse on ball P during the collision? So remember we have this formula that says F net delta T equals delta P, and this is the formula for impulse, the one that you can use. But the thing that we're most interested in is the impulse is the change in momentum. It is actually delta P. So as you can see, sometimes you use this formula and you need the force and the time. We've got none of that information here, but we do know ball P's initial and its final velocity. So we can calculate the change in momentum, which is given the symbol delta P, which will be the final velocity minus the initial velocity multiplied by the mass of the ball. Remember, this mass is not changing, so we could take it out as a common factor. And remember, change, delta P, delta T, whatever it is always final minus initial. So the ball has a mass of 0,16. Remember, we have still got vectors here. Excuse me a second. We've still got vectors here. So because we have a vector, we must consider the sign. We said to the west is positive. So my initial, my final, sorry, because always final minus initial. My final velocity is positive 5. We are still going to subtract the initial velocity because change is final minus initial. But if to the west is positive, initially the ball was moving to the east. So it will be plus 5, subtract negative 10. And as I'm sure your grade 8 maths teacher told you, a minus and a minus makes a plus. So we have plus 5 plus 10, and that will come to 15. And if we multiply that out, we will get an impulse of 2,4 Newton seconds. It says the magnitude, so we don't need the direction. Remember, this one can also be with the other unit. You can use the other unit of kg meters per second. But that is your final answer. Remember, momentum is a vector, so you always need a magnitude and direction.